Trig Identities. Example 2. I'm going to square both sides here to get sine squared theta equals the opposite squared over the hypotenuse squared. I'm going to do something similar on this side, square both sides. Now sine squared theta plus cos squared theta is equal to this fraction plus this fraction. Now we have the same common denominator, so we can combine these two fractions into a single fraction. From Pythagoras' theorem, o squared plus a squared is equal to h squared, so the numerator becomes h squared, and anything divided by itself is equal to 1. So we've shown that sine squared plus cos squared is equal to 1, so long as the angle here and here is the same, and this is true for any value of theta that we choose. So this is an identity. And just to test this identity, I've tried it with 8 degrees and the answer is 1. I've tried it with minus 9 degrees and the answer is still 1. Some very useful rearrangements of this identity include sine squared theta is 1 minus cos squared theta, and cos squared theta equals 1 minus sine squared theta. You should memorize all three of these. Example 3. We have an equation that has a mixture of sine and cos terms. We need to rewrite everything in terms of cosine terms only. So sine squared x can be replaced with 1 minus cos squared x. So that's the objective achieved. Everything is now in terms of cosine, but we should expand brackets, collect like terms and simplify. That would be expected in an exam. So I've expanded the brackets here, collecting like terms and simplifying. If we had to solve this, I could factorize this, and this is not part of the actual question here. The objective was to write everything in terms of cos x, and we've done that. But if we were to solve this, we could factorize, and then we could get solutions from solving this equation and from solving this equation. Now some questions, they say write down the values of cos x, in which case these are your final answers. Others say work out the values of x in a given range of angles, for example 0 to 360 degrees. Example 4, similar to example 3, but we need to write everything in terms of sine x, so we can replace the cos squared x term with 1 minus sine squared. So everything is in terms of sine x right here, but we need to simplify, so expand the brackets, collect like terms, and the objective has been achieved. If I wanted to solve this equation on the calculator, menu, option A, option 2, degree 2 because it's quadratic, and the coefficient for the quadratic term is 3. For the next term it's 2 and then minus 2, and that gives me this and this. So what those values represent are actually sine x. This sine x ratio is between minus 1 and plus 1, so that will lead to solutions. This one is not in the interval minus 1 to plus 1, so we discard this. No solutions from this. Example 5. I have to simplify this expression, and I can see there's a 1 minus cos squared, and I know that sine squared plus cos squared is equal to 1. If I just modify the angle to half theta, I get this, and then I can rearrange this to make sine squared the subject. So what I'm going to do is replace the 1 minus cos squared, which is here, with sine squared half theta. So I've done that, I've replaced that with this. Now the square root and the square will cancel, and sine over cos with the same angle there is equal to tan, so we have tan half theta. So this fraction simplifies to tan half theta. For practice, try these questions.